Next, we are trying to understand frequency and frequency distribution. You would be knowing about the frequency. Okay, note that here what we do is we create class intervals. Okay, we have the concept of absolute frequency. Okay, what is the absolute frequency? Absolute frequency is the actual number of times that the data are coming between this interval. Okay, right? So here when I say interval -10 to 0, I would say that let's say -10 is included, 0 is not included. If a 0 value will come, it will move to the next scale. If 10 degree will come, it will move to the next scale. You have to define, it can be -10 is not here, 0 is here. Whether however you define, you can define. Now what it mean by absolute frequency of 5? That means there are 5 elements which are coming in this range. 10 elements are coming within this range. So if you see the total number of data, if you have 5, 10, 5, 20 number of data is there. So what is the percentage of this on the total? So you have 5 data coming here in this interval, the total is 20. So 5 divided by 20 is your 25%. So we have a concept of relative frequency which gives you an idea about how much is this class with respect to the total. So with respect to the total, how much is this class? So this class is 25% with respect to the total. This 10 by 20 means 50% is this with respect to the total, right? So this is your absolute frequency, relative frequency. Relative frequency is with respect to the total. Then we have a concept of cumulative frequency. Cumulative frequency is the frequency of that class up till the first class till that class. So as an example, this class, if you take this absolute frequency is 5, there is no previous class. So it means that the cumulative frequency of this class will be equal to the absolute frequency. But the next class or next interval, the absolute frequency is 10. So the cumulative frequency will be cumulative frequency of the previous class plus the absolute frequency of this class. So it will give you the cumulative frequency of this class. So 5 plus 10, it will be 15. Cumulative frequency of this class will be previous class 15 plus 5, that will be equal to 20. So this is the cumulative frequency of the third class. Okay. Now similar to the relative frequency, we also want to talk about the cumulative relative frequency. Okay. But one thing you need to know is this, the value of this is 20. It means that this cumulative frequency of this last class will be equal to the total value. Right. Now how do I get the cumulative relative frequency? Cumulative relative frequency will be this cumulative frequency of this class divided by the total, 5 by 20, 15 by 20, 20 by 20. So it means that the last class will be equal to 100%. The cumulative frequency of last class should be 100%. What we can do is, okay, we can represent this interval with a histogram also. This histogram helps you to get a visual representation of the data, that how the data is spread. So which are the classes which have highest frequency, second highest, like that. So if you see this histogram, you have this is -10 to 0, 0 to 10, 10 to 20. It means that the first class has 5. Okay, you get the idea. This is the, so this has the highest frequency. Right? You can also create a frequency polygon. Frequency polygon is created by joining the midpoints of the histogram. Note that this polygon is not complete. What we do is we also join the midpoint of others. So what we will do is we join the midpoints. So this and this. So this becomes a polygon. So you will join with here 0, and then you will join the next one, whatever is the middle value you will join. So this becomes a polygon. So seeing this polygon, you get an idea that okay, this has this frequency, this has this frequency, the frequency of this is this. Okay, and then the others are having 0 frequency. So this is a frequency polygon.